Okay, so hello and welcome again to Engineering Physics, and in this video we would now be discussing about the fifth method in determining the resultant of vectors, and that is to be, well, what you are actually seeing in your screens right now, the component method. So the component method is actually an analytical method, and by analytical method, it is not a graphical method. So unlike in the previous video, we have used their graphical method, and in graphical method what we did there was that we have drawn our vectors into scale. We used our measuring instruments such as our rulers, our metric scales, and whatsoever in measuring the resultant, and we would be making use of our protractors to determine the direction of the resultant of the vector. I mean, of the series of vectors. Okay, so now in the component method, we would now be making use of various mathematical theories such as theories from trigonometry, from geometry, from algebra, and etc. So in this part, we would now be computing. Okay, so the main idea in the component method is that every vector has its own components. So rewording it, every vector can be broken down into components. So let's say that this is now to be our vector. So for example, we have this particular vector here. Okay, so if that is now to be our vector, so according to theory that this vector can be broken down into components. So we have here your horizontal component, and we also have here your vertical component. Okay, so with that, guys, so as you can see, we now have, of course, the horizontal and vertical components. And in a certain vector, of course, a vector must have its own magnitude. So let's say that the magnitude here is to be f. And once again, for a vector, it must have magnitude and direction. So let's say that this is now to be your direction. So this is now to be your angle theta. Okay, so for example, that it is, you already know the value of f and the value of your angle here. You can now solve for this component here and this component here with the use of trigonometry. So let's say that this is now to be your fy, for example. And let's say that this is now to be your fx, or the x and y components of our magnitude f. So from trigonometry, we can remember that from the abbreviation SOHCAHTOA, so so, and TOA. So so means sine, theta is to be equal to opposite divided by hypotenuse. So opposite divided by hypotenuse. So for ka, this is now to be your cosine theta is equal to adjacent divided by hypotenuse. And for your tangent, this is now to be equal to, so tangent theta is to be equal to opposite divided by adjacent. So opposite divided by adjacent. So we can actually solve for fx and fy using these values, these trigonometric functions here. So as you can see, so in this particular triangle, that our hypotenuse is to be equal to f. So with that, if this is now to be your hypotenuse and this is now to be your angle, your fx is to be the adjacent one. So fx is to be the one adjacent to your theta, and fy is to be the one opposite to your angle theta. So with that, so using these trigonometric functions right here once again, so I would just be moving them at the top for us to have space. We can say that for your fx, so let's make use of this value here. This function here, because fx is to be your adjacent. So cosine theta is to be equal to fx, so that is now to be the adjacent side, divided by the hypotenuse, so divided by f. So cross multiplying this would now, you would now be resulting to an equation of fx is equal to f cosine theta. So cross multiplication. Okay, so we already know the value for our fx, and we also know the value for our fy. Actually, not yet. So for the value for our fy, we would now be making use of this. So from that, guys, so sine theta is equal to what is to be the side that is opposite from this angle. So that is now to be fy. So fy divided by hypotenuse. So h, and our hypotenuse is to be our value f. So f. So with that, cross multiplying, our fy is now to be equal to f sine theta. Okay, so it would be as simple as that. Okay, so what if, for example, that you're already given the value for your fy and for your fx? So given that scenario, so for example that you do not know the value of your f and you are given fy and fx, you can actually make use of the Pythagorean theorem for you to get the value of f. So the value for your f, or the resultant f, or the magnitude f, is to be equal to, so f squared is equal to fx squared plus fy squared. And getting the square root of both sides to get rid of this exponent, f is now to be equal to the square root of fx squared plus fy squared. So this is another equation that you should take into consideration. Okay, so what about if, so for example, you already know the value for your fx and you already know the value for your fy, but you do not know the value of your theta. So if you already know the value of your f, you can make use of your sine theta or cosine theta, or better yet, so for example that you want to make use of your fx and fy only, you can just make use of your tangent theta. So with that, guys, so tangent theta is to be equal to, so what is now to be the opposite of this side, or of this angle? So that is now to be your fy divided by, so what is now to be the adjacent of this angle? So that is to be fx. So with that, simplifying this equation, for you to solve for the value of theta here, so just get the arctangent of both sides of the equation to get rid of this tangent here. So with such, we would now be resulting to an equation of theta is equal to the arctangent of fy divided by fx. Okay, so this is now to be the value for our theta. Okay, so you can just memorize all of these things, but truth be told, hindi ko memorize itong mga to. I just know the principles and I just derive it in my mind every time I solve for for problems that are very similar to this. But take note, guys, that if, for example, that your vector, so let's say that this is now to be your vector f, but your angle, so let's say that this is now to be your y-axis and this is now to be your x-axis. So for example, that your angle is to be this one here instead of this one. So if it is to be in reference to your vertical axis, so if this is now to be your x and y component, so let's say that this is to be your y component and this is to be your x component. So we can actually solve for this theta here by subtracting this angle from 180 degrees. Or better yet, instead of doing that, just get this component here and this component here. So as you can see, guys, that this component is equal to this component and this component is equal to this component. So I'm sorry that my drawing is not accurate. So for a moment, so let me just correct our drawing. Oops, I'm sorry. So this is incorrect. I'm sorry. Okay, so there. So if you would now be making use of this particular triangle here, take note that for your fx, so your fx is now opposite to this angle. So if it is now opposite and using this trigonometric functions, your fx is now to be equal to f sine theta and your fy is now to be equal to f cosine theta. So if you are to go back here, so they are now interchanged. So if you can remember earlier that your fy is to be equal to f sine theta and your fx is to be equal to f cosine theta, if your angle is to be in reference with the vertical axis, it would now be the other way around. Whereas your fx is now to be equal to f sine theta And your Fy is now to be equal to F cosine theta. So that is why I do not really recommend you memorizing these formulas. And what I recommend you is that you must understand the concept behind these particular formulas. So, I mean, for you to avoid confusion. Okay, so moving forward, so what is to be the importance of these components? So in adding our vector, so for example, that we would be having this particular vector, then we will be adding another vector here. So let's say that we have another vector here. Then let's say that we would be having another vector here. Okay, so if we would now be adding these three vectors, so if I am to rearrange them in a tip to tail method or a tip to tail arrangement, so let's say that I will be moving this to here, and I will now be moving this here. Okay, so in graphical method, what you would be doing is that you will now be connecting the tail of all the vectors up until the tip of the last vector. So this is now to be your resultant. So let's say that this is now to be your vector A, this is now to be your vector B, and this is now to be your vector C. So the resultant is now to be your vector R. Okay, so what is once again the importance of our components in determining our vector R? So we can actually make use of we can actually make use of those components in determining the value for your R without even drawing them. So for visualization purposes, so I will just leave these components here or this figure here, but I will be erasing this first. So what I will be doing is that I will be getting the components for every vector. So this is now to be the vertical component of our vector A, and this is now to be our horizontal component of vector A. So let's name it as AX. So AX and AY. So assuming guys that all of them have their own direction. So of course it wouldn't be a vector if it does not have any direction. So this is now to be your theta A. So let's say in this particular vector C here, this is now to be, let's say, your theta C. And for your B, since it is now to be going horizontally to the right, it has a horizontal component and it also has a vertical component. It's just that the magnitude of your vertical component is to be equal to 0. Okay, so redrawing this, continuing our drawing here. So this is now to be the horizontal component of your C, and this is now to be the vertical component of your vector C. So once again, this is now to be your Cx, and this is now to be your Cy, considering that this is now to be your theta C. Okay, so for our resultant, so once again, if I am to redraw it, so this is now to be the resultant. The resultant also has a vertical and a horizontal component. So with that, guys, so this is now to be the horizontal component of our resultant. And this is now to be the vertical component of our resultant. So if this is now to be your resultant R, this is now to be your Rx, and this is now to be your Ry. Okay, so using all of these components, we can actually solve for the value for your Rx, and using this vertical component, so by the way, this should be Cy, I'm sorry. So using the summation of our vertical components, we can actually get the value for your Ry. So for the value for your Rx is actually the summation of all the x components. So x, the summation of all x components, but you must consider direction. So let's say, so this is just for an example, it would be up to you on assigning what is to be your sign convention. So I would be assuming that all horizontal components going to the right is to be positive. So there. So that is just my assumption. So if I assume wrong, so if I assume the other way around, It's just that I would be having an answer that is to be negative. So we would be having some examples later on. Okay, so anyway, so that is to be Rx. And as for our Ry, so same old, same old. So the summation of all the y components, and I will be assuming that all of the forces going up, I mean all of the vectors going up, is to be positive. Okay, so with that guys, so I will just be making use of our Rx first. So let us now solve for Rx. So for your Rx, that is now to be equal to Ax plus, so horizontal. So once again, we are just getting this particular summation here. So that is now to be equal to Ax plus Bx. So this is now to be Bx plus Cx. So as you can see, the summation of all of them would now result to Rx. So once again, that is now to be Ax plus, so for color coding, so Ax plus Bx plus Cx. Okay, and take note that this values here can be solved using trigonometry, just like what we have been doing earlier. So f cosine theta or f sine theta, whichever is applicable in the vectors that you are solving for. Okay, so that is for Rx. So what about for your Ry? So for your Ry, once again, that is now to be equal to the summation of x, and I will be considering upward positive. So once again, it will be up to you on your sign convention. Okay, so with that, Ry is now to be equal to, so for your A, its vertical component is going upwards, so that is to be Ay. Thus, this is now to be positive Ay. Okay, and as for B, so for By, since this is now to be horizontal in nature, the vertical component here is exactly equal to 0. So with such, even though if I would now be including this By here, this is still equal to 0. So equal to 0 since this is now to be horizontal. But for example, it is having an angle that is very small. Of course, you must also take it into consideration. So it is not equal to 0 if that is now to be the case. And for your vector C, so as you can see, from this point, so your Ay plus your By is to be located here. And now, since C is going downwards, its Cy is now to be negative. So, minus Cy. Okay, so with that, so you can now solve for Rx and your Ry. Then, once that you have already solved for Rx and Ry, so for you to solve for the value for your resultant R, that is to be equal to, so using Pythagorean theorem, that is now to be equal to Rx squared plus Ry squared. So that is to be for the resultant R. Okay, then what about for your direction? So if this is now to be your angle, so your angle is now to be equal to the arctangent of opposite. So what is now to be opposite of this particular angle? So that is now to be Ry divided by Rx. So Ry divided by Rx. Okay, so you would now be making use of this equation, but this is not to be a general equation because this one would now be interchanged if your direction or if the angle that you are solving for is to be in reference with the vertical axis. So there. Okay, so we will be having an example later on.